So let's consider one more example on waves. And what we have here is this metal ball. And this metal ball, it's given that when submerged in water at a depth of 1000 meters, it is compressed by 5%. So we have this metal ball, and also the density has been given to be 5000 kilogram per meter cube. Now this metal ball, when submerged in water at a depth of 1000 meters, then the volume of the metal ball changes by 5%. So this is given. Now the question is, if you take this metal ball and make a rod out of it, a metal rod, and if you produce wave here by striking the metal rod here, then the waves are going to travel forward. Question is, what is going to be the velocity of the wave by which the waves will travel in this metal bar or metal rod? Okay, so what should we do? Well, at our hand we have the regular formula, which is V equals B divided by rho, where rho is the density of the metal thing and B is the bulk modulus of the metal thing. So B is the bulk modulus. Okay, density has already been given. What is going to the bulk modulus? Now if you remember correctly, bulk modulus is given as change in pressure divided by change in volume divided by the volume. There is a negative sign to account for the change in volume, which is usually negative, but that is just a technical issue, and this will give us the number, and then we are only interested in the number of in the value of the B. So what is delta P? Well, we see this guy has been submerged downward. Here it stays and it's submerged downward in water at 1000 meters. So what is the change in pressure? We know that as we go down, the change in pressure is rho gh, where rho now is the density of water. So it's going to be density of water multiplied by g. Let's take g to be 10 times the h, or the height, or the depth, whatever you want to call it, 1000, divided by the delta V over V. Now we know that it's 5%, so it's 0.05. What do we get? Now we know the density of water is 1000 kilogram per meter cube. If you do not remember it, it's good to memorize the density of water is 1000 kilogram per meter cube, multiplied by 10 multiplied by 1000 divided by 0.05, and that gives us how much? It gives us 10 divided by 5 multiplied by 1 2 3 4 5 6 1 2 3 4 5 6 7 8. So 10 to the power 8, which is 2 multiplied by 10 power 8. Units will be pascals per meter cube. You can simplify it even further, but you can see the unit of pressure is pascal and unit of volume, well, actually no, this is wrong, because this has no unit, so it's going to be just pascals, PA. Okay, what is velocity? Velocity is going to be B over rho, where what is B? Which is 2 multiplied by 10 power 8. And what is rho? And rho has been given to be 5 multiplied by 10 to power 3. And if you solve this, what do we get? We get 20 divided by 5 multiplied by 10 to the power 4, and that is nothing but 2 times 10 power 2, which is 200 meters per second. Now this is some fictitious metal. I may not have chosen the values properly, but in air the velocity of sound is around 330 meters per second. But here we are getting like 200 meters per second. Is because I did not choose the the numbers properly. But usually metals have higher velocity. For example, in iron, velocity is somewhere in the in close to 5,000 meters per second. So just don't rely on these numbers. The main goal was to show you the working.